today we are going to do um, a famous interview question, a very popular interview question called FloodFill. Here is the link to the URL to the problem, where the problem description is mentioned. The URL is here. FloodFill. Basically, the question is that an image is given in the form of a matrix which has various integers in the matrix is a two-dimensional integer array. And to perform a flood fill, the problem statement says that to perform a flood fill, consider the starting pixel. Starting pixel is the input to the matrix, input to your program. Consider the starting pixel plus any pixels connected 4 directionally to the starting pixel of the same color as the starting pixel, plus any pixels connected 4 directionally to those pixels, also with the same color, and so on. Replace the color of all of the aforementioned pixels with the color. So, and the return value of your program should be the modified image after performing the flood fill. So basically, flood fill is any input cell into a matrix is given, and all the neighboring, and your program needs to fill all the neighboring cells of that input matrix with the provided input color. So a color input will be provided. The dimensions to the input cell would be provided into the matrix, and the entire matrix would be provided. So and what is the qualifying criteria for any cell to be a neighboring cell to that cell? The qualifying criteria is that all the neighboring cells in all 4 directions, north, east, south, and west, that is the first criteria. And the second criteria is that the neighboring cell in all the 4 directions would have the same value as the original cell, as the input cell. So for example, in this example, the coordinates of the input cell are given as 1, 1. So that 1 right here in the center. And what would be the neighboring cells that you need to flood fill? This one on the west, one on the north, not the cell on the east because it has a value 0. Even though it's a neighboring cell, it has a value 0, so it doesn't qualify as a neighboring cell for the flood fill. And same thing with the south, it has a 0, so we don't want to flood fill. And so the color that we want to fill in with is 2, and so the resulting output should be only 2 cells that are neighboring and qualified. Those needs to be filled with 2. That's the problem statement. I already explained the problem statement here. What are the approaches that you can solve this with? There are 2 approaches you can solve with. The first approach is the depth first search. So what I will do today is I will explain both the approaches, depth first search and breadth first search, how you can use those 2 algorithms in order to solve this problem. And then I will show you the code that I've written on LeetCode. So for the depth first search, the natural way to solve any problem with depth first search is use recursion. Using recursion, what you will do is you will expand on all 4 directions. Whatever directions are given in the problem statement. In this problem statement, you need to recurse in 4 directions, and so those 4 directions are, like I mentioned, north, east, south, and west. And then so you will expand in all 4 directions and fill the qualifying cells with the input color, provided input color. And what is that qualifying criteria for a cell to be flood fill? Is that the neighboring cell needs to have the same color as the input cell. Then you will change it to the provided input color. Otherwise, you will not. And so there is another. So before I get into the implementation, the way you would do is that you would do this recursively. So there will be 4 recursion calls in all 4 directions, and you will continue in one direction all the way until you hit the end, yeah, until the end of the matrix, and then backtrack. Also, there is no need of keeping track of the visiting cells. This is because your qualifying criteria is that you are going to check for the value of the neighboring cell with the current cell. Because you have already processed the current cell, you have changed the color. So let's say, for example, you started with this 1 and you proceeded in the north direction. So you will color this cell with 2, make a recursive call into the all 4 directions. You'll start with the north direction. You will see that this value is, before making the recursive call, you will store this value in the buffer, and then you will see that this value matches the buffer value. The reason to do this, store this value in buffer, is that you want to FloodFill this cell. If you FloodFill, its value is going to change. Then you will not be able to find the value. If you don't store it into the buffer before changing the value, then you will not be able to find the neighboring cell, because remember, the neighboring cell is the cell that matches the value of the original cell. So first of all, you will store that into a buffer, and then find the neighboring cells, make recursive call into the neighboring cells, and then so on and so forth until you hit the end, and then backtrack and move on to a different direction. Change the color, backtrack, move on to a different direction, and so on and so forth. You will FloodFill in all 4 directions. Let's go to the slides. If there is any other point I would like to mention on this. There is one more point. There is no need to keep track of the visited cells in this depth first search, because you typically maintain a visited matrix to avoid the looping. In this case, you don't need that because your qualifying criteria will avoid the looping. So you FloodFill, change the color, move on to the next cell, and try to find the neighboring cells or neighboring qualifying cells, and automatically you are not going to go back because you already FloodFill it. So change the color, move on to the next one, and then when you look for the neighboring cells, this is not going to qualify because it just changed the color. So you are going to find out these 2 as the neighboring cells, and so on and so forth. Yeah. So let's go through the problem. So here's a description of the problem. This is the input function that you're writing, not the input function, but this is your code, FloodFill. These are the input parameters, the image, the coordinates of the cell, input cell, and then the color with which to FloodFill the input cell and the neighboring cells. If the very first condition right here is if the color matches the input cell, then you want to just return the image. You don't want to FloodFill it. And for For the actual FloodFill operation, I'm using this helper function, which is a recursive function, and I'm passing in these parameters into the FloodFill helper function. What I do here is that I declare the 4 directions in order to visit the neighboring cells. So the x coordinate and y coordinates are 1 and 0 here, 0, 1, minus 1, 0, 0, minus 1, and then I will use these all 4 directions to step by one cell in all 4 directions in the matrix. In line number 12, I'm storing the current value of the input cell, and then line number 13, I'm flood filling it. I'm flood filling the current cell, and because I'm going to change it, I want to buffer it, so I can use that buffer in line number 17 to find out the qualifying cell. So let's continue. In line number 14, I'm iterating through all 4 directions and finding out the next coordinates by simply adding these values, the x and y values. X and y are nothing but the first value is the row and the second value is the column. So I am adding that first value, which is represented by dir 0 and dir 1. I'm adding them to find out the next row coordinate and next column coordinate of the next cell. And so what I do is, once I get those coordinates, I validate the coordinates because they could be out of range, and if they are valid and if they are qualified, and if that particular cell, next cell, is a qualified cell, which means it matches the input cell's buffered value before the flood fill. If that is the case, then that's a valid cell, and I'm going to flood fill that also in the recursive call. So in the recursive call, I pass in the new coordinates, and then buffer those, and then I repeat that process, buffer the coordinates, and make another recursive call in the same direction. Now, if it is not valid, or if it is not a valid qualified neighboring cell, then I will backtrack, and in which case the function will return right here, and I will continue in the for loop by processing in order to process the next direction. In this direction, I will find the next, this is the row value, and the column value is, and this is the column value, so I'll move on to the next column on the same row. So basically I'll move on to the east direction, and I'll repeat this process, and every time in the recursive function, I'm going to buffer the value and then flood fill it. So that's it. By the end, when this function returns, I return the image with all the flood fill values, and this is going to give this is going to run in order. Let's see the runtime. So the runtime complexity of this program is order m cross n, where m is the number of elements in the row, and in each row, and n is the number of elements in each column. So because you're visiting every element only once, and flood fill it, and then backtrack it, and visit the non-visited elements. So, and the space complexity is constant. There is no additional space needed. You traverse the input matrix, and hence the space complexity is constant. So that is the depth first search approach. In the breadth first search approach, Okay, so this is the breadth first search approach. What you would do is essentially in a breadth first search approach, you use a data structure called queue. Queue is a 5-4 data structure, first in, first out. You insert an element into the queue, and then when you poll an element, the first inserted elements gets polled, is popped out, and then you process that element, process all the neighboring elements of that element, and basically in our problem we will flood fill by processing what we mean is we flood fill, and we then find out all the qualifying neighboring cells and then insert them into the queue, and you do that, you continue this process until the queue is empty. So I declare the queue data structure here, and then I initialize my current position with the input coordinates, and then add that into the queue, buffer the first image, buffer the first input position of the image, flood fill the input position, and then use that buffer right here in line 21 to find out all the qualifying cells. Here I process until the queue is empty. I pop out the first element from the queue, which is essentially the first element that I inserted, our input element SR and SC, and use this all 4 directions to find out the next the coordinates of the next cell that I'm going to process. If that next position is valid and if it's a qualifying cell, then I will flood fill it, and I'm going to add it to the queue. Here I don't need to buffer that value, because this is not a recursive function, and so I'm going to use this the original buffer, so I don't have to buffer it every time. It's going to be the same, that buffer. So I'll use that buffer value and use that in line number 21 to find out all the qualifying neighboring cells. I do this in all 4 directions with a for loop here in order to find the qualifying cells in all 4 directions and flood fill them. And by the end of I will continue to do this until the queue is empty, and then return the image at the end. So this is the breadth first search approach. The runtime complexity will be order m cross n, and the space complexity is constant. So so basically you can use both the approaches, depth first search and breadth first search, to solve this flood fill problem, and the runtime complexity is the same for both. So yeah, that's all, guys. Thank you very much for listening to me, and please like this video, share this video, and please let me know in the comments what you guys think about it. Thank you. Thanks for listening to the problem.